Hi friends, welcome to my channel. Today we will discuss about screening effect. In last video, I tell about the atomic radius and the periodic trends, how atomic radius increases in the periods, how atomic radius increasing in the groups. Okay, if you don't see that video. Now after next we will discuss about screening effect. Screening effect is the one of the factor which affecting the atomic radius. Okay, this is in this video, screening effect is very important for all competitive exams. Okay, first, what is in the screening effect? Now, I am drawing an atom. This is the nucleus, first cell, second cell, and the last cell, last cell, third cell. Okay, in first cell, how many electrons are present? In first cell, they are present 2 electrons. In second cell, there are 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. In third cell, present 18 electrons. We take some 2 electrons present in the third cell. Okay, what is the definition of sealing effect? The definition for the screening effect is the repulsion from the inner electrons to the outermost electrons is known as sealing effect or screening effect. Okay, now we will discuss about deeply to the screening effect. I am rubbing this one now. I am writing definition. Okay, now we see the definition of screening effect. The repulsions from the inner electrons towards the outermost electrons or outer electrons by decreasing the nuclear charge is known as screening effect. In this screening effect, you know, same charges, positive or negative repel each other because they are same charges. Like charges repel each other. When you take positive negative, it will attract each other. Okay, these both repel, this one attract because same charges repel each other and the opposite charges attract each other. In this way, in screening effect, the inner electrons, suppose I am drawing atom here, rough diagram, first cell, second cell, let us only. This is the 2 electrons present in the first cell. In outer cell, 3 electrons I am drawing, 1, 2 and third electron. In this electron, you have to know this is a positive charge. What is the charge of electron? Please comment in the comment section. The charge of electron is negative. In this way, positive charge and this negative charge both will attract each other. That is known as the attraction forces of from the nucleus. Okay, this from this electron and the nucleus, so many attraction forces between them. And this electron is negative charge, and this electron also negative charge. Negative charge, both will repel each other. I have written it here. They both will repel each other. In this way, they reduces the attraction from the nucleus. This is only known as sealing effect or screening effect. Why that name will come is the inner electrons seal the attractions from the nucleus to the outermost electron or outer electrons is known as the sealing effect. Another definition for the sealing effect. In this way, the decreased nuclear charge is known as effective nuclear charge. Effective nuclear charge. I think you understand what is meant by the sealing effect briefly. Now we discuss about the effective nuclear charge. What is meant by effective nuclear charge? By the sealing effect, the repulsion from the electrons towards the outer electrons. In this process, the attraction from the nucleus of an atom will decrease. The decreased attraction from the nucleus is known as the effective nuclear charge. Now we discuss about effective nuclear charge. How to find the effective nuclear charge of an atom. Okay. Now we will discuss about effective nuclear charge. The attraction from the nucleus is decreased by the sealing effect. The decrease in nuclear charge or the decreased attraction forces from the nucleus is known as effective nuclear charge. is known as effective nuclear charge. Effective nuclear charge. Okay. Now, for an atom, for every atom, they have distinct effective nuclear charges. When the effective nuclear charge increases, the atomic size decreases. This is a very important point. I think it is visible. When the effective nuclear charge increases, atomic size decreases, because effective nuclear charge means the attraction forces from the nucleus. When the attraction forces from the nucleus increases, then the atomic size of an atom decreases, because attraction is more, the electrons come near to the nucleus. When the effective nuclear charge is decreases or very low, the atomic size is more, because attraction is less, then the electrons won't come near to the nucleus and they go away from the nucleus. In this way, the conclusion from this statement is electron effective nuclear charge is directly proportional to 1 by atomic size or inversely proportional to atomic size. That means effective nuclear charge increases, atomic size decreases. Effective nuclear charge decreases, atomic size increases. Now we see how to find the electron effective nuclear charge of an atom by the shielding effect. How to find the shielding effect and how to find the effective nuclear charge by some formulas. Okay, the general formula for finding the effective nuclear charge is effective nuclear charge is equal to Z means atomic number of that element. That means atomic number minus screening constant. Okay, what is the formula for effective nuclear charge? It is known as atomic number minus screening constant is gives rise to that effective nuclear charge. Then how to find the screening constant? Okay, suppose you take an atom. Just it is very simple. Suppose you have to find the screening constant of some electron H. Okay, that electron. And for that electron, we have to write the configuration of the element like NS1, NS2, NS2, that like so on. 1s1, 1s2, 2s2, 2p6, 3s2, 3p6, so on that like ns2, np6 and d10 that like. We have to write the configurations in cell-wise manner. Okay, in cell-wise manner you have to written the configurations. That means first cell, second cell, third cell, fourth cell, that like. For you take the general configuration like this. Example, you take the calcium. What is the atomic number of calcium? Z is equal to 20. Then the general electronic configuration of the calcium is 1s2, 2s2, 2p6, 3s2, 3p6. How many electrons? 18 electrons. This is the configuration of argon. 3p6 and 4s2 next. I written in the cell-wise manner. This is first cell and this is the second cell, third cell and this is fourth cell. Okay, this is known as valence cell. That means N. This is penultimate cell. I said in the previous class only. This is cell said to be N-2 cell. That means anti-penultimate cell. And the remaining cells is known as the inner cells. Okay, or core cells. Okay, I divided all into 4 cells in the cell-wise manner. Now you have to find the screening constant of 3s electron. The electron present in 3s. What is the screening constant? For 3s, what is the definition of screening effect? The repulsion from the inner electrons. That is very important point. The repulsion from the inner electrons. That means these inner electrons only provide the repulsions. That means the screening constant have been calculated through these inner electrons only. The outer electrons after this 3s2, the outer electrons won't participate in screening effect or shielding effect. So you ignore these electrons. Okay. Now you have to keep concentration or the left side of the 3s2 electron. Okay, first 3s1 contains, this is n cell. What is the sigma is equal to screening constant 0.35 into number of electrons present in nth cell. That means nth cell means not the valence cell, the electron which you are finding that cell in place 0.85 into number of electrons present in n minus 1 cell plus 1 into number of electrons present in remaining cells. Okay, I think you understand. Okay, first we have to how to find the screening constant means 0.35 into number of electrons present in the n cell. N cell means not the valence cell here. The electron which we are finding, that electron present in which cell, that cell is known as the nth cell. Next 0.85 into number of electron present in the n minus cell. N minus cell means the cell just before to the nth cell. Then 1 into number of electron present in the remaining cells. After that n minus 1 cell, the remaining electrons present, the cells calculate 1 into number of electrons. Okay, we know this formula. Okay, now we find the screening constant of the 3s electron in a calcium. This is known as calcium element. First, in this 3s2 electron, we have calculating only 1 electron. So 1 electron screening constant. So we have to ignore that 1 electron and starting from the 3s1. 3s1 is the nth cell. 1 into 0.35. This is first one. 1 into 1 electron present in the 3s2. We ignore that we have finding 1 electron. We ignore that electron and starting from 3s1. 1 into 0.35 plus in the second cell, how many electrons are present? 2 into 2s2, 2 electrons are present, and the 2p6, 6 electrons are present. Total 8 electrons. 8 into, in n minus cell, how many? What the value? 0.85. 8 into 0.85 plus after this 2s2 2p6, the n minus 1 cell before, that means just before that all the cells, 1 into number of electrons. In this one cell present. In 1s2, how many electrons are present? 2 electrons. That means 2 into, what is the value? The value is 1. 2 into 1. For this value, we calculate these values and find the screening constant of calcium. Okay? Okay? Now, 1 into 0.35 is 0.35. 8 into 0.85, I do the calculation here. Now I am doing for the 0.85 into 8. 8 5 is 40, 8 8 is 64, 6 8, 6. 6.8 is the final value. 6.8 in 6.80 plus 2 into 1, 2. 6.80 plus 2, 8.80. 8.80 plus 0.35, 9.15. The screening constant of calcium is 9.15 for the 3s electron. Okay. Now we have to find the effective nuclear charge, means we have to calculate the valence shell electron. That means 4s electron. Okay. I am telling briefly. 9.15 is the screening constant. Screening constant of 3s electron in calcium. Now you have to find the effective nuclear charge of that electron in calcium. Effective, how much attraction from the nucleus experienced by that electron. Okay, that effective nuclear charge will be calculated. That formula I am rubbing this one. I am writing the value sigma is equal to 9.15 for 3s electron. We are finding the 3s electron. Then the Z effective nuclear charge is equal to Z minus sigma. What is the Z value? 20. 20 minus 9.15. Okay, it is known as the 20 minus 10. 10, 10.85. 10.85 is the effective nuclear charge of calcium. Okay, I think you will understand this class. In this way, we are finding the effective nuclear charge of an electron in an atom, or we have to find the electron effective nuclear charge for atom is for effective nuclear charge of calcium. This like questions asked means we have to find the 4s1 electron spin constant and subtract z minus sigma. In this way, we are finding the effective nuclear charge. Okay, today I am giving for you some questions. Okay, in comment section you keep the answer for questions. That one. First question. Find the effective nuclear charge of zinc for 4s electron. Effective nuclear charge of 2s electron in lithium. Okay, in this way, first you solve these two questions and keep the comment section. These are the two questions for this day. And how the effective nuclear charge and screening constant is related to the atomic size. Effective nuclear charge increases, atomic size decreases. In this way, effective nuclear charge is inversely proportional to atomic size. Screening constant is directly proportional to atomic size. Okay? Screening constant is directly proportional to atomic size and the effective nuclear charge is inversely proportional to atomic size. Okay friends, thank you for watching this video. If you like this video, please share to other members which are you think useful to us. Okay, thanks for watching this video. Please subscribe.